It's quiet, not peaceful quiet, not the quiet of a sleeping house or a still lake at dawn. This is the quiet of a universe that has forgotten how to make noise. Every star is gone, every galaxy, every nebula, every burning thread of hydrogen plasma that ever lit anything up. Gone. Not destroyed, just finished, used up. The last one burned out so long ago that even the memory of light feels like mythology. And yet, something remains. It doesn't glow. It doesn't pulse. It doesn't announce itself. It just warps the nothing around it, bending the geometry of a universe that has nothing left to bend. This is the last black hole. And here's the thing nobody tells you. It's dying, slowly, imperceptibly, but it's dying, evaporating into the void one quantum particle at a time. Like a block of ice the size of a solar system, sublimating into a vacuum so cold, it makes the coldest place we've ever measured feel like the surface of the sun. And when it goes, that's it. No curtain call, no successor. The universe will have produced its final event, its final anything. But here's what I need you to understand before we get there. Before we follow this thing all the way to the end of time itself. The story of the last black hole isn't just a story about death. It's a story about what death even means when there's no one left to witness it. Stay with me, because this next part changes how you see everything. Right now, tonight, you're living in the most luminous era the universe will ever know. That sounds dramatic. It is. Cosmologists call it the stelliferous era, the age of stars. It kicked off about 100 million years after the Big Bang, when the first hydrogen clouds collapsed under gravity and ignited. And it'll end roughly 100 trillion years from now, when the last red dwarf star, a dim little ember barely massive enough to sustain fusion, finally runs out of fuel and goes dark. 100 trillion years sounds infinite. It's not. On the scale of what comes after, it's barely an introduction. Because here's the thing, after the last star dies, the universe doesn't end. It keeps going. For a duration so incomprehensibly long that every number I could throw at you would fall apart the second I said it out loud. So what inherits the universe after the stars? Black holes. Every galaxy has one. Ours has Sagittarius A. 4 million solar masses of compressed spacetime sitting at the Milky Way's core. The giant elliptical galaxy M87 hosts one that's 6.5 billion times the mass of our sun. And as the universe ages, as galaxies keep grinding into each other in slow motion, as gravity just keeps doing what gravity does, these things merge, they devour each other, they grow. By the time the last star burns out and the universe goes dark, what's left is a population of black holes at truly absurd scale. We're talking objects that have swallowed entire galaxies whole, billions of solar masses, trillions, and then slowly, so slowly that no clock we've ever built could track it, they turn on each other. Two black holes meet. Their event horizons touch, they spiral, they merge. One grows. One ceases to exist as its own thing. Then it happens again and again, over timescales that make the current age of the universe look like a rounding error, until only one is left, the last black hole. And now, here's where it gets wild, because being the last one standing doesn't mean it's safe. In 1974, a physicist named Stephen Hawking did something that basically broke physics. Or rather, he found a place where two theories of physics couldn't agree with each other. And in that disagreement, he found something extraordinary. He proved that black holes aren't permanent. Not loud, not dramatic, not a nova, not some massive explosion. Black holes die the way a rumor dies. Slowly, quietly, one small loss at a time. Here's what's actually going on at the edge of a black hole right now. Space itself isn't empty. At the quantum level, the vacuum is a constant, seething churn of particle pairs. Matter and antimatter flickering into existence for a fraction of a moment, then annihilating each other and giving back exactly the energy they borrowed. It happens everywhere, all the time. You're swimming in it right now. But at the event horizon of a black hole, something different happens. A particle pair appears right at the boundary. One particle falls in, the other escapes. The one falling in carries negative energy into the black hole. The black hole loses mass, one particle at a time. We call this Hawking radiation. And for a stellar mass black hole, the kind born from a dying star, the temperature of this radiation is so cold it makes the current cosmic microwave background look like a furnace. We're talking temperatures so low they have more decimal places of zeros than most calculators can even display. The evaporation timeline for a stellar mass black hole, roughly 10 to the power of 67 years. For a supermassive black hole, the kind that'll be the last one standing, we're looking at 10 to the power of 100 years. That number has a name, a googol, 10 to the 100. And here's the thing about a googol that should stop your brain cold. The current age of the universe is about 13.8 billion years. Written as a power of 10, that's roughly 10 to the 10th. A googol is 10 to the 100th. That's not 10 times longer than the universe's current age, not 1,000 times longer. The gap is so extreme that every ratio you've ever used to compare anything becomes laughably completely useless. But the black hole doesn't care. It keeps evaporating. Patient. Inevitable. The last clock in a universe that has otherwise stopped counting. Let me put you there. You're floating in the deep future. Let's not even try to name how far out. Time has become almost theoretical. There's no stellar cycle to count, no seasons, no day and night, no cosmic microwave background to speak of anymore. It's redshifted into wavelengths so long they barely qualify as electromagnetic. You look around. There's nothing to see. And dark doesn't cut it. Darkness implies the potential for light. This is something else entirely. This is a universe that has structurally forgotten photons. But ahead of you, not visible, but detectable by the geometry of space itself, by the way your trajectory curves, by the way your instruments go haywire, is the black hole. Your body feels it before your instruments even register it. A pull, gentle at first, same sensation as an elevator starting to go down. Then less gentle, your blood wants to move toward it. The fluid in your spine shifts. Your inner ear loses the concept of up. There's only toward and away, and toward is winning. If you cross the event horizon, if you fall past that boundary, you wouldn't feel an impact. There's no wall, no membrane, just a mathematical surface, a line in space-time that the universe has decided is one way. On this side, escape is possible. On that side, nothing, not matter, not light, not information, comes back. Your body would stay intact for a moment. Then gravity's gradient, the tidal force, the difference in pull between your head and your feet, would start its work. Slowly at first, then not slowly at all. You'd stretch, not metaphorically. The technical term is spaghettification, which sounds almost funny until you understand it describes your body being pulled into a thread of matter thinner than an atom, stretched across thousands of kilometers, still technically alive at the molecular level for a fraction of a second that looks from the outside like an eternity. But here's what nobody talks about. From your perspective, you don't experience that. You experience falling, just falling. The horror is that it's peaceful, right up until it isn't. And by the time it isn't, the universe outside has aged by trillions of years. You fell in, and outside, the black hole kept evaporating. Still, patient, eternal, or close enough. Here's something almost nobody realizes about how a black hole actually ends. It doesn't fade quietly. The smaller a black hole gets, the hotter its Hawking radiation becomes. That's the terrifying math at the heart of this whole thing. As mass drops, temperature rises. As temperature rises, radiation intensifies. As radiation intensifies, mass drops even faster. It's a feedback loop, a death spiral. And near the end, it stops being gradual entirely. The last moments of the last black hole, after a googol years of near total silence, become a burst, a flash. The final evaporation of a stellar mass worth of compressed history, released in a blaze of gamma rays and high-energy particles, so intense that for one brief instant, It'd be the brightest event in a universe that had been dark for longer than our entire current cosmic age. And then, silence again. But this time, genuine silence, complete silence. Because now there's nothing. Not dead stars, not cold planets, not black holes, not even the geometry black holes used to impose on spacetime. The universe keeps expanding. But expansion of what? Space itself, stretching whatever subatomic particles remain farther and farther apart until the distance between them makes any interaction impossible. No force can reach, no information can travel. Causality becomes a relic concept. Physicists call this the heat death. Maximum entropy, not a bang, not even a whimper, a condition. A universe that's exhausted every possible state change. A universe that has, in the most technical sense you can imagine, finished. And it was a black hole, the last one, that kept the final account. That processed the last of the mass, the last of the energy, and paid it all back to the void in one final, extraordinary flash of light. We are living, right now, in the bright morning of the universe. Everything that burns, everything that shines, every star being born tonight in some distant nursery cloud of gas and dust. It's all happening in the opening chapter. The universe is 13.8 billion years old. It's got something on the order of a Google year still ahead of it. We're not witnessing the end. We're witnesses to the very beginning of the universe's long, slow, magnificent exhale. And the black holes, they're not the villains here. They're the custodians. They're what the universe trusts with its last reserves of structure, its final ordered repositories of mass and energy, its last statement that something was here, that physics applied, that cause produced effect. The last black hole won't die alone and forgotten. It'll go out in a blaze that, if anyone or anything were there to see it, would be the most extraordinary light show in the history of existence. The universe's final signature, its last proof that it was ever here at all. We exist in the one era where looking up at the night sky means seeing fire, actual fire. Nuclear fire, sure, ancient, violent, indifferent, but fire, real light, crossing billions of light years to land in your eyes specifically tonight, at this exact moment in a universe that will be dark for so much longer than it was ever lit. You're not an afterthought of the cosmos. You're its audience, right at the precise moment worth watching. And somewhere in a future so distant it dissolves the concept of distance itself, the last black hole will go out, and the universe will have nothing left to say. The question is, does that terrify you? Or does it make the light overhead feel more precious than it ever has before? I know which one it does for me. If this left you unsettled or strangely moved, subscribe. There's a lot more where that came from. The universe has a whole lot more to answer for. The last black hole, what happens when the universe runs out of everything?